Okay, last time where we ended up was right here on this slide when we were looking at how to integrate user input into our PDO queries. And in this particular case, is the slide we left off at, right? The query string parameter we fed directly into a query and then ran it. This is sometimes known as, I don't know, concatenating your SQL queries or something along those lines. And what we left off with is we said, hey, this works. It works just fine, but it's a major security risk here. It's something called a SQL injection attack. And let's see what a SQL injection attack is and why they're so nasty. Okay. So let's imagine we have some kind of a form and users type in their data, and then here you can see in this case it's post data, not get data. And notice how we're concatenating or we're inserting into a string our user input directly. Well, this is an image from the first edition of the textbook, so it's not using PDO, but it doesn't really matter. It's running the query. This ends up running a query that looks maybe something like this, right, where we have the user input and everything works just fine. However, what happens when someone doesn't type in what we expect, but instead types in SQL directly into an input field? Now, this might look a little weird, but you can see, oh, look at that, a quote, and then a semicolon. You might recall in SQL that a semicolon ends an SQL statement. Intriguing. Well, if we actually took that input and put it into here, what do we get? Well, this is what our query looks like. We're going to say select star from users where username equals empty. So you can see that quote and semicolon there finishes that statement. Now we've got a brand new statement. We're going to actually get rid of that, empty the records in that table, semicolon, right? And then the pound symbol there indicates a comment, and so anything else just gets commented out. So bad news. So this is one of the oldest and most popular security vulnerabilities in the web world. And so what we want to do is we want to try to avoid making any database code that we write, we want to avoid making it vulnerable to this particular attack. So what's the solution? Well, the solution is to never trust user input. 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 Yeah, you get it. What's user input? Well, form data is clearly user input, but query string data in a URL is also user input. Cookies are user inputs, though we don't really know how to use cookies yet. HTTP request headers potentially are user input as well. But again, we don't probably have to worry about that one. But these first two, we absolutely have to worry about right now. Okay, you might be saying to yourself, I don't trust user input. Now what? Well, two main strategies. The first is sanitizing user inputs. That's actually can be quite tricky, and there's lots of funky workarounds that people will make to try to bypass sanitization efforts. There are third-party libraries. There's one from Google that's quite good that you can use for sanitizing user inputs. But for us in this course, in terms of database queries, what we can generally rely on is just using something called prepared statements along with parameters. So let's take a look at what that is. Prepared statements. Let's take a look at this code. So here, some of this is familiar, right? Creating a connection, constructing our SQL. But notice right here, instead of actually putting in our user input like we did earlier, we're going to just put a question mark. That's our parameter. We're saying something is going to go into there. We're going to retrieve our user input and put it into it, in this case, just a temporary variable. And here, instead of running query, we're going to run prepare. You can see prepare takes an SQL statement, and it returns a statement object. That statement object has a bind value method that we can use. And this bind value is how we, in a sense, populate this question mark with data. The one here means the first question mark. We might have more than one, and then it would be 1, 2, 3, etc. The data value that we want to bind into this. And then we actually run the query or execute the statement. The bind value and the execute, in a sense, make sure that there's no SQL injection and things like that. In a sense, it makes it so that our query is relatively safe. We can then do fetches or loops just like we did before. Okay, so nothing has changed. So it's only a couple of extra lines, and that's definitely worth it. We can also make use of named parameters instead. So here you can see that instead of having a question mark, we provide a name. And that name begins with a colon, and then you can have any name you want. And then when we use bind value, you can see that we just provide the name. This will make sense for things like insert or update queries, which often have multiple parameters, maybe 8 or 10 or 20 parameters, and 8 or 10 or 20 question marks in a query in a SQL statement looks pretty ugly. And using named parameters makes some sense. Again, you can take a look at the textbook on pages 664 and 665 to see an example of using named parameters with an insert, I think, an inserts SQL statement. All right, the next thing I want to talk about is designing data access, how to make our code better. So far, you've more or less seen how to do all the SQL that you'll need to in this course. Still, there's improvements that we can make. As it says here, it's not uncommon for a PHP site to have multiple pages, maybe dozens or even hundreds of PHP pages. And many or even most of these pages may need to run one or more SQL queries. It would be a maintenance nightmare to scatter PDO code on all of those pages, right? Especially if you've got dozens or hundreds of pages. Instead, what you want to do is you want to localize your database access code within functions, or even better perhaps classes, which you put into separate files, and then you include them when you need them. So take a look at this and do remember this. You don't want any PDO code in your markup. That's one of the things. So when I go to mark your assignments, I'm going to see, do you have PDO code in your markup? If you do, you're going to lose marks on the design side. So let's take a look at one way of doing this. So let's begin. Let's create a file here. Let's call it dbhelpers. Oh, here I got .inc.php, but I forgot to type in the .inc. No worries. You can see that we're maybe going to include our configuration options where we specify our connection string and username and password. So here we're going to encapsulate the connection code into a function. You can see it. Oh yeah, we've seen those two lines before. And we're also going to encapsulate our code needed to run a query into a single function called runQuery. You can see it. We're going to pass in the connection that we get back from this thing. We're going to pass in an SQL, and then we're going to pass in an array of parameters if we need them. You can see that what this code does is if parameters wasn't in an array, it'll put them into an array. It will then loop through that array and actually, whoops, I did a little shortcut that we haven't actually seen. Instead of looping, I was going to say loop through the array doing bind value, I forgot that execute, you can actually pass in the parameters directly to it, and then it does the bind values for you, which makes life a little bit easier. Yeah. And if there's no parameters, it just runs a old-fashioned query rather than a prepare. And then it returns the result. All right, let's take a look at it. So let's use it. So here's our sample page, and we're going to include that helpers that we've just created. Right? We're going to create the connection. Remember that connection is inside. Get connection is inside of this function, inside of this library. We're going to run a query. In this case, with no parameters. Right? So you run query. So we pass it null, and then we're going to run another query in which we have parameters. Okay. Remember, we pass in the SQL. Maybe we do stuff with this data. Here I've put it as if it's all in together. Maybe displaying the data happens further on, lower, in the middle of your markup. And finally, when we're all done, we're going to close our connection. So this is an improvement for sure. Right? We don't have any PDO code in our markup, but we still have SQL details in our markup pages. And just like our other pronouncement, ideally we don't want any SQL in our markup, right? So if we go back to here, right, look at this. There's SQL. That's a database detail there inside of our markup page. And that's not what we don't want that. So here's an alternative solution that's pretty close to what we want. Let's encapsulate all the queries relating to a single table. Remember, maybe we have a gallery table into a separate library named after the table. So here I've got a file. I probably would have called it .inc.php, but never mind that. And so it uses our helper library that we've just created. And each table will likely need a function to get all the records, right? Getting all of them. And probably a function to get just a single record using the primary key, right? But again, we're making use of the helper functions. Here's a similar, and we're going to do this for each table. So here's one for painting. So previously, right, that was for gallery. Here it's for painting. Got a bit of code duplication here. The code for kind of get all paintings and get all get all galleries. It's kind of the same except for the table name and the field name. We can maybe improve this eventually using classes, but let's not worry about that right now. And depending on your requirements, each table's library can have its own unique functions. So let's go back, well, maybe our gallery, all we really needed to do was get all of them or get a single one. Maybe paintings, we've got more complicated requirements. We need to not only get all or a single, but maybe we also need to get maybe the paintings just for a particular gallery, or maybe the paintings for a specific artist, or things like that. So the idea is that we can add in the functionality, the database functionality we need for that table. Then our sample page, look at this. This is much easier. So now we just include the helper. Well, not the helpers, but these ones that we've been just creating. We include those, and then use them, right? Get all galleries, get paintings for a gallery based on user input, and then we can, do stuff with these results. So galleries and paintings are result sets. So compare this to our sample page from 4 slides back. It's much simpler code. Let's actually take a look. Let's go back 4 slides, right? Right, this is the 4 slides back. You can see that this had SQL, it had connections. It was a more complicated. So it's certainly much simpler code. However, there's a major problem with this solution. It's also a minor problem. The minor problem is that we never close our connection. That's not as big a problem as the major problem. The major problem is this, connections. Connections are like unicorns. They're a very scarce resource. Most database systems only really allow you to have maybe 32 or 64 connections. So if we're hogging up 3 or 4 connections, that's bad news. Every time you create a connection, it's very slow. Quite often your database management system is on a separate computer, so it's very slow to make a connection. Another way of saying that, this line, whenever you say, something equals new PDO, that's a very slow line of code, like very slow line of code to execute. So the code that we've just looked at on these previous couple of slides is nicely encapsulated, but the problem is each function is creating a new connection every time they're called. If your page is calling several of these functions, your page is going to be so slow. So if you find, as you're maybe working on your second assignment, and your page is taking 10 seconds to run or 20 seconds to run, or even 5 seconds to run, it might be because you're making more than one connection. And if that's bothering you when you're running it, imagine how it's going to bother me as I'm marking it. Pro tip, you do not want to make me annoyed while I'm marking your assignment. So this is a problem. You've got to make sure you fix this problem. So this means you must only connect to the database once on each PHP page. Just in case you missed it, you must only connect to the database once on each PHP page, please. So what we've done so far on these slides, we're going to have to refactor. Refactor just means we're going to have to improve it. So a nice simple solution, which we'll look at here, is just to pass in the connection to each function. So in our original, each of these functions created a connection. The improved version is that we pass in the connection to the function, and then we don't have to create a connection. This is much, much better. This is all we really need to do to make our code 675% better. Okay? So then our sample page, it's maybe not quite as beautiful as it once was, but it's not so bad, right? We're going to get the connection, okay? And then, actually, I've forgotten something. We also need to include, what did I call it? DB helper, helpers.inc.php. I think that's what I called it. So there. So we, because get connection is defined inside of DB helpers. So we get connection, get all galleries, get all paintings. You can see here that we're passing in the connection. The nice thing about this now is we also solve our minor problem, meaning that we can actually close the connection. So it's slightly more complicated, but it's much more efficient in terms of its connection handling. All right, we are done.